I am very excited to bring Max on board. Can't wait to hear about his vision for a database for every developer.
Thank you.
Thank you.
Thank you, Kavaja. Okay, cool. Hi, I'm Max. I'm the CEO and co-founder of PingCAP. You can feel it. I'm still, engineering style CEO. So I'm really excited to be here to share some of our journey to build a super scalable serverless database. And I'm also a little bit nervous. I haven't been talking about technical details for about 2 years. So as a, engineering style CEO, I'm really, really into it to talk about lots of, technical details. Well, here is the agenda. I'm going to talk about, an introduction of TiDB and PingCAP a little bit. I will be, as fast as I can. Then I will spend most of the time to talk about the journey of building a TiDB serverless. I believe many of you have already tried, serverless databases, but how to build a serverless database is super hard. We spent 5 years, And I will talk about OSS Insight, which is an open source dashboard for all of the open source projects that are hosted on GitHub, and how we actually, leverage the AI to build it. And then I will introduce, the key capabilities of TiDB Serverless, and then some of the developer resources. Okay, cool. So here is a short introduction. We are the company behind the open source TiDB. TiDB, how many of you guys have, tried TiDB or ever heard about TiDB? Raise your hands. Okay, cool. Definitely, we need this introduction. So TiDB is a super scalable, and it's open source database that is compatible with MySQL protocol. And so basically, you can treat TiDB as a bigger, larger, MySQL. And how we make it serverless would be a really interesting story. And we are 8 years old, and we're based on Sunnyvale, California. And we have more than 500 employees globally. And here, I hope you guys remember this number. We got 600 million total funding, which is related to our journey of building a serverless database. And here are some of our users, customers, and I noticed some of our customers are actually here. For example, Databricks. Of course, as a technical guy, I will try to share the journey of build TiDB Serverless. Super excited. Just give me a while. I'm so excited. No, I still remember the first time I tried a serverless product, and then I don't want to use any other products that is not serverless. Once you try it, you never want to try to maintain any system that is not serverless. So I'm really into serverless. 5 years ago, I talked to our CTO, Ed. Is it possible that we build a free database for every developer? At the beginning of this event, Kawaja introduced, hey, we need to think big, right? We should have, big dream. So we asked two questions. Is it possible? And another one, is it affordable? I believe you guys still remember how much money we actually get from investors. So we did a quick math. Here's the number. How many developers actually, worldwide is 26 million developers. Try to do a simple math. If you provide a free database for every developer and you multiply to, 27 million, how much will it cost? Now, since we have, well, I'm not going to say lots of money. We have, some money. If we can use money to solve this issue, that would be a really simple issue, right? Money can solve lots of issues. Then we did a simple math. We need 2.8 billion per year to provide a free database for every developer. I thought we got some money, but now I think that's a joke, right? Not yet. Yeah, we can last for a year, half a year, or just a few months. Oh, I forgot to mention, we need elastic, load balancer. We need to calculate the storage costs. We need to, add some nodes for high availability. They need another, 800 million. So in total, we need 3.6 billion per year to provide a free databases for everyone. Well, I haven't added the costs for storage, the monitoring system, and it's too scary to calculate all of the costs. And in nowadays, AI is super hot. AI will help us to get 10x more developers. So we need to prepare more money. Any investors here? Raise your hand. Oops, no one. So obviously, this is not a good way to make it. Then what do? We gave up. Since I'm still here, I guess you guys already know the story. We gave up the traditional architecture. It's like, hey, I am using a traditional, database such as, MySQL, or Postgres, or whatever. You want to make it a truly serverless, and you want to make it free to everyone. With traditional architecture, you need lots of money. But to save some money, the theory 2080 theory, right? Most of the clusters are actually not active at all. So why not just shut it down? When we use serverless. So what is serverless? If you're not using it, you don't pay for it, it scales to zero. Actually, you just shut it down, right? So we spent some time to rethink about the architecture. Is it possible that we change the architecture to reduce the costs? For example, let's see, 100 times. 1,000 times. Is it possible? So anyone who wants to build a serverless service, I know you guys already tried different serverless service, but to build it, it's actually pretty hard, right? This is just simple math, right? Yeah, that's serverless architecture. If you can shut it down, and Kawaja is definitely the one who is the best, who has the best understanding of serverless. And he, I still remember he mentioned one of the rule you can judge if the serverless thing is good enough is if you can scale to 0. If not, well, you need to pay for it. It's super expensive if you want to provide it to 27 million developers. So we move on one step more, and we try to make it possible. So how many of you guys have tried spot instances? Oh, man, you guys must be really rich. So if you're using AWS, you should try spot instances. If you are using spot instances to do some calculations or really heavy computations, you can actually get close to 70% off discount. So let's see, we saved 70% off. Multiply 3.6 billion US dollars. I don't have the money, but I feel like, wow, I saved a lot of money. And we've talked about 80-20 theory. 80 of the clusters are not active at all. So just shut it down. You saved 80%. So we are engineers. We do a quick math with our mind. So what's the results? Cool. You got results? I don't. So I use ChatGPT. And to make sure it gives me the right results, I use the code interpreter to make sure, it is calculated by Python code. Then we still need 200 million per year. Still, I can't afford it. It's super expensive. But think about that. We have 600 million funding, so it's affordable at least for 3 years, right? We can contribute to the society, right? Then we started to rethink about the whole architecture, and to make sure, from the technical side, we can build something that's really, make it happen, to make it real. And here is the architecture. And I know you guys probably understand the architecture of Snowflake, right? How many of you guys have, heard about, or look at, the paper, the separation of computation and storage? Raise your hands. Well, cool. A few. So basically, we'll talk about this later. So basically, it's a really classic principle. It's a separation of compute and storage. A few years ago, when we talk about, hey, this is a cloud native thing, if it's not, designed as a separation of compute and storage, it's not really cloud native. If you are trying to build a data warehouse or data lake things, it has to be, the separation of compute and storage. But is it enough? to separate the compute and storage. To further reduce the costs and make the system more stable, since we are trying to build a database. We're not trying to build a data warehouse. You can tolerate a few seconds, tens of seconds, latency or a spike, whatever. But for an OLTP database, we cannot tolerate the spike workload, the latency. And what if we do something like separation the compute and compute? So what does it mean, the separation of compute and compute? Actually, you guys have that kind of experiences, which is separation, the lightweight compute and heavy compute. So still, it's not easy to understand what does it mean for a lightweight compute and a heavy compute. Yeah, tell me more. Yeah, we've used cache, we've used DynamoDB or some other databases or any key value store. If you're trying to just read a few records or trying to query with indexes or read-write a few records, or you're trying to run some kind of money transfer, small transactions, these are really lightweight compute. But have you tried to add an index to a big table? For example, if you have 1 billion records, 1 trillion records table, you have to batch it, right? That's a good idea. But how long will it cost to add index for 10 billion table? If you're trying to add an index, you need to read a row, then decode it to get a specific column. Then you build index for that specific column and add a pointer to the row ID, right? And also, if you want to change a column of a table or remove a column of a table, it's really heavy, or you probably tried, hey, I want to analyze a table, I want to get statistics of a table. How many of you guys tried, analyze table? Raise your hands. Wow, you got lucky. Or you scan the whole table, right? Which is really heavy. And, many of the databases actually has the feature, you can compress your data. And if you're using MySQL or PostgreSQL, you can actually compress a page, right? Which is really heavy computation. And of course, there are more. So what we do, we offload those heavy computation to dynamic microservices, which is running on top of Spot instances. That's why we saved lots of the money. And by the separation of compute and storage, we can improve the CPU utilization of those lightweight transactions. Usually, when we write our own applications, our own services, we are actually running those lightweight transactions, unless you are trying to do some kind of data analysis. So we improve the CPU utilization by 2x, which we saved 50% of the money. Now, it's just 100 million per year, which means it's close to 3.5 or 6 per database for every developer per year, which is affordable. 100 million. Right, not just PingCAP. There are many other companies can provide a free database for every developer in just 100 million per year. So we can last 6 years, right? Then we realized it's possible, and we made it. We are so proud of it. It's hard to believe. The architecture actually changed everything. You changed my age. I'm 5 years older.
Stress.
Yeah. And that's TiDB Serverless. That's the whole journey of TiDB Serverless. And, we actually didn't stop there. We moved further. As I mentioned, we actually do the separation of compute and storage. I just showed we actually improved the CPU utilization of those short transactions, those lightweight computation. So it's not just about money. It's more about the user experience. After the separation, you can actually fully leverage the architecture. Let's take a look here. Come on. Okay, cool. Let's look at the architecture again. Since we offload those heavy computation to microservices, so we can actually use Spot instances to compress the data with those better algorithm to get higher compression ratio to further reduce the costs. If you are running online transactions and with the same database, and you want to compress the data, you want to get a higher compression ratio, you don't have enough computation resources. But if you can offload it, you can run as fast as you can. We keep buying AWS Spot instances. We keep rotate based on the lifetime of Spot instances. That's why we can actually make it happen. And here, since we store all of the data on top of AWS S3 or any other shared storages, and we can get much higher durability. And since you can offload the adding index process, you can actually get 100 instances to build index concurrently. Then you just load the index file into your online databases, so you can be 100x faster or even faster if you want. This is totally different from traditional database design, and this is super useful when your online workload, hey, your database is getting slow, I want to add an index, but usually it's too late. But with this kind of design, you can actually make it really fast. And of course, you can create a branch just like you use Gate to create a branch of your source code. You can create a branch for your whole cluster. This is super cool and it's super useful. And of course, you can back up your database with just a few seconds. Since all of the data already stored on S3, you just build the meta information and store it. That's it. You finish the whole backup process. And thanks to S3, you get much higher durability. It's if I remember it right, I could be wrong, it's 11.9, right? I could be wrong. Okay. And you can actually, since we provide high availability, so basically you have 3 copies of your data. Let's imagine if one of the node crashed. You just got 2 copies, right? You need to recover your data to 3 copies ASAP. Right? Traditionally, you need to pull the data from other nodes. But with a new design, you can actually pull the data from AWS 3. So it's super fast. Cool. So here is an example that running on top of TiDB Serverless. Also inside, which stands for open source insights, open source software insights. So it's an AI-powered dashboard for all of the open source projects hosted on GitHub. Let me take a look. Okay, cool. There should be music, right? Okay, cool. So basically, you can ask any questions on any repos, or any programming languages, or any open source metrics. And we actually use OpenAI to translate your questions into SQL. So we just run those SQL on top of TiDB Serverless. Then you get results, and it will show the results with a specific charts. For example, line charts, bar charts, pie charts, and these visualization options are actually generated by OpenAI. So ask any questions, OpenAI will translate it to SQL, then we run this SQL, and then we get results. There are lots of prompts, and that's why 6 months ago I became a prompt engineer. Yeah. So I got my understanding on lots of prompts. I remember that Alex mentioned it's pretty hard actually. It's about 2,000 lines of different prompts to make it happen, and also make it amazing. Previously, imagine you want to build something like this. You want to build a flexible dashboard that can answer any questions, and you want to run it on top of a database or data warehouses. Previously, without AI and without serverless, it's not possible. Why? Because those generated SQL is really flexible. You have no idea what kind of SQL will be generated. It could be, run on top of specific repo, on specific, contributor. And you need to get results really fast, since I'm not going to wait for 10 minutes to get results. So imagine if you are the project owner, if you are trying to build an application like this, how will you architect the whole project? Probably you need a database, you need data warehouses. When there is a SQL generated, you will try to send this SQL to different sources. For example, you send it to database and you send it to data warehouses. Then who will give me the results first? I will use that results. But if you are trying to send a complex query to OLTP database, it will die, or you will never get results. And here are some of the data. Of course, the whole project is open source. So it's reproducible, And you can take a look at the prompts if you want to be a prompt engineer. And here we have 12 terabytes of the data. It's keep growing. We keep pulling the data from GitHub. It has over 6 billion rows of the data. And as you can see, it's keep pulling the data and show it on the right corner. And those SQL are generated by questions, so it's mixed. You have no idea what kind of SQL it is. So every time you look at a slow query, it feels like, am I really built this application? Since everything is fresh new every time, a different question came out, you get a fresh new SQL, you have no idea, how to optimize it because you don't write it. And one more interesting story. I remembered one night, OSS Insight showed up on the top page of Hack News. Oh.
Why did you end up on Hack News? Why they end up on Hack News? Why?
We don't know. Someone just posted because of a specific, dashboard. Have you guys tried, or maintain any open source projects? Who is the maintainer of any open source projects? Wow, cool. So definitely you want to know, any of the metric of your open source projects, right? If some of the, metrics growing really fast, you will have a really good, dashboard. You want to figure out why. Then someone, posted it to Hack News, the pop-up. We get, 7 times more traffic at that night when we were sleeping. So, since we're using serverless, it scales in and out automatically. Just like, if you are using the, cache from Momento, you don't need to care about, how many, servers I'm using. Everything is just, so smooth. I add some more details to the architecture, because the, SQL is, it's generated by natural language, so it's quite, ad hoc, and it could be really complex, or it could be super, easy to understand. So I add some more details here. It's MPP, massive parallel processing, because we provide hybrid capabilities, hybrid transactional processing and analytical processing capabilities to TiDB. Here is an example. And this is really simple SQL. You can actually, run this SQL on top of, a database or on a data warehouses. But, the beautiful thing is you can force, TiDB to run it on top of, row storage, or on a pure columnar storage. Here we force, here we read from the storage, we have a hint, and TiDB is the row storage. As we can see, all of the tasks running on top of the row storage, which is TiDB. So the time it costs is 285 milliseconds. Then we force it to run on top of columnar storage. Here in TiFlash, flash means it's run really fast. The TV show Flash, right? So all of these queries are running on top of a columnar storage, and it takes 400 milliseconds. Then we use the optimizer to make that decision. The optimizer actually generates a hybrid query plan. So partial of the query running on top of the row storage, and the table scan for the orders table actually running on top of a column store. So we can leverage both row storage and column storage at the same time. So you get much lower latency. It's 49 milliseconds. I guess this is probably the first time you see something like this, right? This is the first time, what is HTAP? How do you actually, get feelings of HTAP? And here are some other, examples of different data sets. You can try to explore it. And of course, serverless is a pay-as-you-go model. And after, we finished TiDB Serverless, we didn't stop there. We tried to make it even powerful by leverage, large language models. So we built this Chat2Query, I just mentioned 7 months ago, to make sure it can, use any, how many of you guys have actually used any, GUI tool to operate database, PHP, MyAdmin, other, database tools or Visual Studio? So we integrate this feature to TiDB Serverless. You can just put some comments there, and the large language model will translate your comments into SQL, and then you can run it to get the results. This is super cool. It helped me a lot. It helped me, lose my SQL skills. After this, I can't really write complex queries. And of course, chatbot. Everyone is talking about, chatbot. We integrate it too, And we also, integrate it to many different, platforms or frameworks or tools. And I actually want to talk more about, the technical details, how we build it, any, technical questions. So I got 10 minutes. So any technical questions, technical details you want to know, feel free to ask. Thank you very much. Oh, thank you.